have that as 10 meters long, and with a vertical cross section is an equilateral triangle. So I draw the shape is like the upside down triangle, and when you have water put in or out, the cross section of the water, like this, I might change the color. For this bit is always equilateral triangle. Okay, so what we want to see, like show that the area of the ends is always equals to h squared over root 3, where h is the vertical height of the triangle, like the volume of the water is h. So if I draw this triangle out, like say this is the cross section of the water, and the height of that is h. Okay, the height of that is h. That's 60 degrees. So if I say this is A, okay, so this length, the equilateral triangle's length is A. What we will have is a sine 60 degrees equals to h over A. So I need the base, okay, but the base will be all the same. So if I work out this A, it's the same as this base here. So I can work out any length of the equilateral triangle. So A is just equals to h over sine 60 degrees. Okay, so times A and divide the sine h. What we'll have is h equals to A equals to h over root 3 over 2. And then times 2 on both top and bottom is 2h over root 3 for the base. Then the area equals to a half times base times height. That time base times height. So which is a half times 2h over root 3 times h, which is the given one, which is h squared over root 3. Okay, this is the cross section of the water. Okay, of the water. So that cross section area change according to how high is the water, like what's the height of the water in the trough. Okay, that's the first part. And the second one said find the volume of the trough in terms of h, of the water in the trough. So the volume must be the uniform cross section times by 10. Okay, so the volume is the base times by height. So it's a street one. So it's just the base times by height. It's a h squared over root 3 times by 10. And some of you asked me the next one. Water leaks from the trough at this rate. Okay, when you want to write d watt over d watt, as you look at the unit, meter cubed must be talk about volume. Minute is must talk about the time. So what we have here is dv dt. Okay, think about that. This volume we talk about is the water in the trough. So what is the water actually leaking out from it is the negative value. So we need to have negative 5 here instead of positive 5, and which is the same question as what we do in the topic test, and the last one is that you lose a mark because of that. So it's a negative 5 of the rate of decreasing. All right. And find the rate at which the water level is falling. Okay, so when we didn't say like regards to which one, we are talking about dH over dt. Okay, so we could not say compared to that one, it's always compared to time. So it's dH dt. And because we all talk about the volume and height before, we know this is a relative rate of change question. We have dH dv over a times dv dt. We know dv dt is negative 5. And we have a relationship between V and H. Okay, so we can work out dV dH here. Do you have any questions? No? Yeah? No? Good. Okay, so we have dV dH is 20 over root 3H. And then we need dH dV, we need to flip that. So dH dV is root 3 over 20H. Okay, so we have root 3 over 20H times by negative 5. we simplify, we'll have that. Okay. That's all revision for previous exercise. And if we have a look at the next one, find the rate of water is falling when the depth falls to a quarter meters. So we want to work out dH dt given that h equals to 104. Okay, I'm not going to put that in the test. You can work out that by yourself. Well, it's actually very easy. If you start a quarter in, there's a 1 on the denominator, and there is a negative root 3. Okay, so it's a negative root 3. So you might want to answer that. Yes. Yeah, you will you won't answer. You won't say this is a positive root 3 directly. You say the water falling at a rate of root 3 meter cube per minute. You're not going to. I marked. I can't remember which paper I was marking. I see some students directly do that. Negative root 3 equals root 3. I know you're trying to answer this is a positive rate of change, like answer in a positive rate, but you can't just directly change negative root 3 to root 3. So the rate of decreasing. You can leave as mandatory. I don't think there's a problem for that. For unit, it's not that harsh like marking on units, but if you know what's the unit, you can just write it down. Like if you know that's definitely meter cube per minute, so better write it down. But it's not that harsh to mark on that. Why write millimeter? It's a height. So it's a meters per minute. Yeah. Right. So my exercise is the last question, which is directly revised on what we learned yesterday. I can't find a proper wording question with you yesterday, but this one will be a good one. So basically, when it leaks into a depth of a quarter, so it's no longer losing water. Okay, stop the water, no longer losing, and then the water is added in at a rate of 4 meter cube per minute. So now we are adding water into the trough. So if I use dV over dt in this situation equals to 4. Okay, so that's a positive rate. Let's forget about what's happening before. So we start the time at 0 now. Okay, so let's assume that's when time equals to 0. Like we restart the system, and then water at the initial amount is h equals to a quarter. Okay, that's what we think at the beginning. So we don't think about how long it takes for me to lose until we have a quarter of the height. So what we assume is when t equals to 0, we have a height of h equals to a quarter. And now we start to add water into the trough with dV dt equals to 4. And you know that the dH, from that dH dV, because that won't change. That's still root 3 over 20h. Okay, that's still root 3 over 20h. Because it doesn't matter you lose water or you gain water in the trough. The amount of water, like the cross-section of the water is always equilateral triangle, and this always satisfies, like V is always equals to the area times by 10. So we still have this dH dV here, but instead we have a positive rate of change for volume. Therefore, my dH dt equals to those two times together, which is 4 times root 3 over 20h. Same way as what we do before. Okay, which is root 3 over 5h. We have a differential equation here. Okay, we have a differential equation here. Okay, when you have a differential equation, and then see what it's asking, how long does it take to fill this to a depth of 1.5 meters? So what we have now is t equals to 8, t equals to 0, h equals to a quarter. And I want to ask myself, t equals to what? I have my h equals to 1.5. Okay, this is what I'm interested in. So I want to work out the time. Okay, let's think about like a hard method. When we have this differential equation, how we can solve for it? I can't directly integral that. need to flip it. Okay, so we have dt dh equals to 5h over root 3. Can I solve for that? Yeah, I can solve for that in t in terms of h, right? Like t something h. And then we can plus a c by substitute 0 and a quarter in to work out the c value. And then sub the point 1.5 in to work out the time. That takes like about, like that's worth maybe 2 or 3 marks. Okay, all this working what I just described. Flip it, anti-diff that. Sub the value in to work out c, and then sub the 1.5 in to find the time. It takes a longer time to do it. Let's think about this. If we have the test, okay, everyone, this is really, really important. If I have this differential equation, I can treat this as dy dx. Okay, so my t is actually y. I know it's weird to think about time is y, which is the independent random variable, but let's think about just according to what we have. That's a dy dx situation. So t is the y value and h is the x value. So what I have is if my x value equals to a quarter, the given y value equals to 0. And like what I want to figure out is at 1.5, at my x equals to 1.5, what my y value equals to. Okay, what my y value equals to. So in this case, what I have is t bracket 1.5. Okay, I want to work out that, which equals to the given x, which is the quarter. And the x I'm interested in to find the y value, which is 1.5, over like integral the dy dx, which is 5h over root 3 dh, plus the given y value, in this case, which is a 0. Okay, the given y value, which is a 0. So we plus a 0 here, or you don't need to write that. If I can type this directly into the calculator, if you realize that, it's much more easier compared to we solve out all of that and then sub 1.5 in and then solve for that. So we get the answer like in 2 seconds after we type that in. Okay, do we get that? Any questions? Do you remember the formula? I need to have the a to b fx dx and then plus the d. AD is the pair. AD is the pair. And this in this case the y value is 0. So we plus a 0 there. Alright, any questions? The last one is really important. Yes? Yeah? It should give you the same answer. So t, well in this case if you look at that, t should be 5 over 2 root 3h squared plus c, right? And then we need to substitute time equals to 0, and then that equals to a quarter squared, and then work out c. C equals should be negative of that. Do you get that? H in terms of C. I'll have a look at that after I finish that, and I'll have a look at your answer. Okay? You should get the same thing. If it's different, it will be incorrect. Which one? This part? The red thing? Yes, like that's what we learned yesterday here. I haven't typed that in. I'll type that in to see. Here. This one is what you need to know. That's the important formula. Everyone, I need to move on. If you have any, if your answer is not matching with the answer actually I have, I will go through that with you when I finish the teaching, and I will see all individual answers and see what's wrong. Okay, please have your notes out, and then we go 9H today. for this exercise, I have the same kind of information. I know the derivative, and I know a point on that graph. This exercise is estimation. Okay, so the answer you get out is not the actual answer, it's estimation. So why we want to do estimation? Couple of reasons. Like first reason, it could be I don't have cash, and I don't know how to solve this antiderivative. Like I don't know how to solve the differential equation. For example, just this one. It looks really easy, but I don't know how to solve for that. Okay, it's not 2x times y, it's 2x plus y. You can't subtract the y to the other side, like what we learned the separation of variable yesterday. So what we need to do here is, like, I can't solve this, and if I don't have cash, I can't solve for that. So I want to use some method to estimate a value. Okay, so to estimate a y value. So just go through the basic introduction. So what's this method looks like on graph? So if I know this point is a comma b on the fx graph, okay, this is the fx graph, and I know a point already. I want to estimate a value, say this value here, a plus h, where h is a really small value. Okay, so my graph can't really draw it too tiny, like, but assume it's a very small value, say h is 0.01 or something like that, or 0.1. So how I can estimate that? So I don't know the equation for fx. All I know is f dash x. Okay, f dash x is what is given to us. So I know the derivative function, but I don't know the actual function. And I can't solve for the actual because I don't know how to introduce that. So the estimation will be, if I draw a tangent at this point a comma b. Okay, look at the straight line. This is the tangent at the point a comma b. What's the gradient of this straight line? Yep, f dash of a. Thank you. So the gradient of this green line will be f dash a. So what is my estimation? What is my estimation? So I want to know the y value here. Okay, I want to know the y value here. But I use this value to say it's approximately equal to the top one. So the point on the tangent line, like this point, I use this value to approximate this point here. So they are very close. You can see if h is small enough, the tangent is really close to the actual graph. But if I take a value here, it's a very big difference. Like that's the difference. It's too much difference. So I can only use this method to find value which is close to the given point. Okay, so close to the given point. Okay, let's think about that. If I have this point, which is a plus h, which is the x value, and then the question mark is the y value, like the unknown y value. This is the value I want to figure out. And I say this value will be the estimation of the actual f a plus h. Okay, that's the estimation height. What I can do is question mark minus the value of b over a plus h minus a should equals to f dash a, which is the relative rate of change. Okay, y2 minus y1 over x2 minus x1 equals to the gradient of the linear. And you just told me the gradient of the linear is f dash a. So which I can solve for the question mark here. Okay, so the bottom is just h. Well, a little bit similar to the first principle. No, 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 no. This is nothing you need to really remember and write on your paper. Like I'm just showing you how and why it works. Okay, you don't need to write question mark. I just don't want to introduce another variable here. It's a lot of variable already. It's just more obvious to use question mark. We can see this part equals to the previous point height, like which is b, okay? Which is this part plus the h. H is what? Is the increment between this point to that point, like that's the h. Times what? Times the gradient of that point. Okay, the gradient of that point. So again, which is chart x equals to 7. You're not going to use h equals to 3 to work on it. Because you can see when I increase h value, there's a lot, like a huge difference between the actual value and the tangent. Therefore, I will use this method to repeat the same step for a couple of times. I can use a width of 1. I can estimate from 4 to 5, and then 5 to 6, and then 6 to 7. Okay, to a couple of steps. If you are patient, I can go 0.5 to increase each time and go 6 steps to work on it. Therefore, we have this formula here, which is on the formula sheet as well, which is the Euler's method. So what that talks about is the next x equals to the previous x plus h, which is like how many steps that you take. So from 3 to 4, that's the first estimation. 4 to 5, that's the next estimation, and 5 to 6, and then 6 to 7. So that takes 4 steps to estimate that. And the y, the new y equals to the previous y, okay, previous y, add on h times by the derivative of the previous point. Okay? And it's either that you might get equal to f bracket of that. So it can be in terms of both x and y, or only x, or only y. It depends. So it's the derivative of the previous point, not the current point, it's the previous point. So that's the formula. I'll just do one example with you and show you how to do this on CAS, because most likely that will be a multiple choice question, and you can use your CAS directly to work out the answer. So let's have a look at this one. Use Euler's method with h equals to 0.5 to find an estimate for y correct to 4 decimal places when x equals to 3 for this equation. Okay, I want to estimate x equals to 3, y equals to what? With the initial condition x equals to 1 and y equals to 0. So this is a certain point. It's a point on this graph, definitely on this graph. So I will always start from the given point. Okay, my habit, if I don't have calculator, and my habit of doing this type of question is start from x value. So my x0, the starting, the initial x is 1. Okay, the initial x is 1. And I want to work until x equals to 3. With each step takes 0.5. Okay, with each step takes 0.5. So my x1 should be what? So 1.5, 3 on 2. And the next step will be 2. And then the next one will be 2.5. And the last one will be, well, I know this is the last one because I stop at 3. This is what I want. I will finish at 3. So that's x4. We work until x4. Now I will go back to think about what is my y value. My y0 is what? Y0 is what? 0. Okay, so the given value is 0. All right, y side is always the side like difficult to think about. So y1, okay, always think about it's the previous, okay, it's the previous point. So it's the previous y value plus 0.5, which is the h, okay, the step, times by the derivative of the previous point, which is the derivative of the previous point is 2 times 1 plus 0. Okay, so that's the gradient. You use that equation to stop those 2 points in. Okay? All right, what is that equals to? That's a 1, I think. Yeah? 2 times 0.5, which is a 1. We can check out the answers later by using the calculator directly. Okay, the next step will be the previous y value plus by 0.5 times by the previous point's derivative, which is 2 times 1.5 plus 1. Okay, you stop, in this case, you stop 1.5 and 1 into the dy dx, the previous point derivative. Okay, so it's 2 times 1.5 plus 1, which is 3 plus 1, which is 4. 4 times that 2, 2 plus 1, 3. Yeah, that's a 3. Okay, you can keep going for the next two, but I think I want to show you the calculator first. You can spend a little bit of time to work on the next two. You must write this instruction down because it's a really long one. Because it's a really long one, this instruction. I take a couple of years to remember it, to be honest. Well, I know this instruction from I was in year 12, but like I take a couple of years to remember it. Okay, so there's two places to find this. You either just type that in, okay, just type the word in like by your keyboard, or you can find it in the book. See the book 2 button next to 9, and then you can type E. Yeah, just type E. You start beginning with E, and you go down to find U, which is in alphabetical order. So you can click on that, which is this one. The first thing you want to go type in is the derivative. So in this case, my derivative function equals to 2x plus y. Okay, so your derivative function equals to 2x plus y. And then the next thing is comma x comma y, like the independent random variable and then dependent random variable. So it's dy dx, so x first and then y. And then the next thing we want to type in is a curly bracket, like comma and a curly bracket. So control and the right hand side of the right round bracket. So control and the right bracket to have this curly bracket here. Okay, what's into curly bracket? Must write that down. The first value is the x0, so it's the starting x value, so it's your x0. So in this case, my x0 is 1, so I press 1 in. And comma, what's the next value here? Is the last x value you want. So the last x value we want is 3. So when x equals to 3. So it's what you want to work out. So first one is 1 and the last one is 3. So from 1, estimate until 3. And comma, after the curly bracket, I press comma, which is the y initial, like the initial y value. In this case, it's a 0. So in the curly bracket is actually the 2x value, and then outside the bracket is the initial y value, and then comma 0.5. Yes, step size, which is the h. You know why it takes me a couple of years to remember that now? Kind of. You get a matrix C and you can see all the steps. Okay, so 1 give you 0, 1.5 give you 1, 2 give you 3, the next one will give you 6.5 and 12.25. All right, make sure you write the instructions down. One last thing I want to talk about is a question in GitHub 2 years ago, I think. Still, if I can still the same question, exactly the same condition, and I want to ask you, if x equals, like initial condition is x0 equals to 1, y0 equals to 0. If I'm asking you what x equals to negative 1, y equals to, like how you can work on that. So I changed the question to exactly the same. Instead of x equals to 3, y equals to what? I want to x equals to negative 1, y equals to what? Good thinking, h negative. What else? Like, say still, I just want to change this instruction. Which two numbers I need to change? Okay, question first. Do I go negative 1 to 1 or 1 to negative 1? 1 to negative 1. Okay, so you still want initial at the beginning and what you want at the back. So it's 1 to negative 1. And what else needs to be changed? Y won't be changed. The step size, negative step size. Okay, negative step size. Because you are going backwards, it's actually minus the 0.5. So they're adding a negative 0.5. So that is what you need to change. Okay, so it's quite surprising a couple of years ago. Oh, there's a negative 1, and I hope students can get that. So if you go 1 backwards, and it's a negative 0.5. So if I press enter here, it will give you the value work backwards. 1.50, negative 0.5, and negative 1. Okay, you can see that as well. All right. I'll stop here now, and if you have any question for the beginning one I have, I can go through that with you for the next 5 to 10 minutes. Any questions for this lesson? Calculator instruction is important. Make sure you write that down on your book reference or under that question if you use that as book reference. And practice a couple of questions in the notes as well. Okay, there are quite a lot of questions for Euler's method in my notes, so just practice a couple of them.